my name is Dr. Žana Stevanovic and I came from Institute of National Importance Vinca from Republic of Serbia. The aim of this project very interested me, first of all, because my expertise is from part of thermal environment and thermal behavior of population that lives in the residential area. I'm also a part of a research group that works on projects for energy efficiency in buildings. We as a group have worked already in 8 national and international projects worldwide, and I have already have several commercial projects and I have worked on hotels, schools and other parts of residential area. As this project wants to see the goal, we can first of all can talk about Serbian policies, and the Serbian policy for this type of building with high density of population, first of all, is defined in a rule book of condition, content and manner of issuing a certificate on energy performance of buildings, which is directly licensed by Chamber of Engineers in the Republic of Serbia. What we do in Institute Vinca, we are managing with experimental measurements, first of all directly on buildings, and after that we are implying different mathematical solutions for and developments, different scenarios for giving different results for this type of buildings. What we want to do is to improve, first of all, thermal comfort in this kind of building. The problem is very complex for this type of building because first of all these buildings are very high, they have very high level of population inside of these buildings, and what we are facing these days a problem of climate change in everywhere. So first of all we can see the very high and intense risks for this type of buildings, even when we are looking at envelope of this type of buildings. What I have chosen is city of Belgrade. As we can see, Belgrade has high level of analyzing meteorological data in form of typical meteorological year, and it's very different from current meteorological data that we are facing on the location. Typical meteorological data are on averaging 4 meteorological stations in Belgrade, so they are formed by averaging 4 meteorological stations, and we can't use that data for different parts of the city. So in this type of project we want to use the nearest meteorological station from location that we are looking and want to improve energy efficiency in the building. For the location, I have chosen 3, I call it neighborhood in Belgrade, they are strategically pointed in east, south and west. They are specifically targeted because they are from communistic era, and they are built in 1980s. They are from the architectural point of view type of towers, because every one of these structures are heighted more than 80 meters. They are part of brutalist style that was very defined in this socialist era, and they are defined with two materials, with concrete and steel. What we are facing today, first of all, I want to say that they were built because they were presented the meeting point of East and West. So we have Eastern Gate and Western Gate of Belgrade. That was a symbolic part to show that East and West is meeting in Belgrade. That was a symbol of these towers. This complex, East Gate, is, as I can already said, typologically brutalist style, and it has 85 meters, and it is part of, we can see, 3 buildings. And from our point of view, in every building, minimum population is 450 people, and at Eastern Gate, population is 1,700 people. On the west side, in the municipality New Belgrade, we can see Westgate. Westgate is a combination of 2 buildings with their architectural solution on the rooftop in the form of restaurant, and its height is over 80 meters. It is also brutalist style. Our estimation is that more than 500 people are living in this building. On the south of Belgrade, we have a neighborhood called Vidikovac, and we have 5 buildings, and the estimation there also the height is over 80 meters. We have 20 floors, and estimation is over 2,000 people that are living in this area. What we want to do is to improve energy performance in the buildings. That's the main target of European standard for every residential buildings. But what the most important is that thermal comfort is a very big issue, and thermal comfort is opposite of energy efficiency, because it's a subjective point of view of resident. Thermal comfort is defined in the specific European standard, which was developed by Funger's research. And what Funger defined is that optimum performance that for every residential population is a maximum 95% that can be satisfied. What we can see that 5% is always dissatisfied with every reconstruction and with every improvement that we can do. 5% in this high intensity, high density population is a very big number. So this will be a great challenge for this type of project. Also, what we want to see is that goal of project, from my point of view, also should be a game changer material for improving reconstruction based on thermal identity of mass buildings. Now we are facing with lots of ecological material that can improve envelope of the building, and also we have that's one strategy, and the second strategy would be improving on the HVAC system, heating, ventilation and air conditioning, and we could do that with lots of sensors, and we can see what we can do directly on location. First of all, we have to scan what kind of systems are developed in this type of buildings. And the least one is that our goal is to provide high level of satisfaction in the consumer, so that we can have at least 10% of dissatisfied people with improving this strategy, or what the study can show to do, and to have improvement on thermal environment in these buildings. Those three areas were built in 1980s, and after 40 years the whole thermal environment around them has changed, and also the urbanistic plan has already changed. In first two locations we can see that there is a lot of urban city center, and on the neighborhood of Vidikovec we can see a large part of green area with also great connectivity with the city center. What we are doing, we first of all doing measurements on every location to see how temperature rise or drops in these buildings. Also, every measurement that we are taken is validated, and we are doing verification of this kind of measurement. Then we are doing questionnaire with the residents, and we are targeting the problem. We want to see where the problem is. And when we are facing with this problem, we are doing scenarios, and in scenarios we can see how much value for money could be taken for each scenario, and we gave several solutions for residents. Also, we want to improve this building and give best advice in this study. What we want to do is minimizing risk of climate change and also minimizing risk of transformation this type of buildings. And what we want to do in study to also show what stagnation and not doing anything on this mass house building can do for the risk of the health of population and residents that they are living in.